Hello guys. So recently I posted a video about how to work with Arduino using WCH chips, and some of you asked me some important questions on YouTube. So I'm going to answer some of those questions right now, and also further illustrate how to work with Arduino in WCH. Okay, so one of the major questions that was asked is, what hardware did I use to set up the system? And for that, we used two pieces of hardware. The first one is the WCH Link E, and then the second one is a CH32V003 development board. As you can see right here, so the first one on the left, the first one here is the WCH development board, the CH32V003 development board, and on the other side is the WCH Link E. Now, I'm going to show you how to set up the basic connections to configure this board, and also I'm going to run some sample Arduino code to test some of the most common peripherals. So this video is going to be divided into a series of steps where I'm going to brush off on things that I missed on in the last video, and also answer some of your answer some of the questions that you've asked in the last video as well. So let's begin. Step 1, how to set up this development system with Arduino. As I said before, provided you have the WCH link and a CH32V003 development board, then you can begin programming Arduino with WCH. So the first step is you need to download the Arduino IDE, and then once you've downloaded the IDE, the next step is you need to go to GitHub and you need to search for OpenWCH, which is the GitHub repository for WCH related code. And then in repositories, you're going to search and look for the CH32 Arduino repository. In there, if you look at the README file, there's a URL. Now you want to copy that URL and then open your Arduino IDE. As in my case here, I've reset everything on my Arduino IDE so that we can begin to read. Now, on a side note, if you're having problems deploying your link or establishing a connection, that could be because you do not have the proper drivers installed. To do this, you can go on the WCH webpage and download the WCH Link E driver and make sure it's installed. Or if you already have Mount River Studio, then the driver will be in there, and you can see it from the Mount River installation folder. You can see the WCH Link driver, and you can install it to make sure that your WCH Link works. Now, the second question that I got asked the most was, how do you connect WCH Link E with CH32V003? Okay, so the basic connections are pretty straightforward. So on both ends, you connect ground to ground, VCC to 3V3, and then you connect the SWDIO pin to PD1 and the RX to PD5. And that is how you connect the board. And then the other question, so the last step, the other question that I was asked is, how many peripherals are supported in Arduino by WCH? You can check all the information and also further information about configuration and customization on the CH32 Arduino GitHub repository. But I'm going to be releasing another video testing different peripherals in Arduino for WCH chips, especially the CH32V003. So I'm going to be testing GPIO, UART, SPI, and making sure that everything is working. Okay guys, as stated before, I'm going to show you some examples of how we can use and manipulate the peripherals provided to us in Arduino using WCH chips. So I'm going to be using some of the simple peripherals in order to show you how they work and how you can apply to them. So first things first, I'd like to point out that if you have any questions about WCH Arduino, make sure to visit our GitHub page and post an issue. And there also you get access to the Arduino core for WCH, which includes some critical information like maybe some pin definitions, and in case you want to go deeper. So I'll first run the most basic example, which is of a GPIO toggle. Now, so this is to test if GPIO is working, and for our lead pin we're going to be using D5, which can be translated to PC3 for the CH32V003 board. So from here onwards, it's the same. We're going to upload. Okay, as the video shows here, the LED is flashing on and off, which means that our GPIO program is working. So now for something a little bit more challenging, we're going to be testing the UART in our Arduino. So it's the same thing as before, but this time we are going to push. We're going to compile and also upload. So what this program does is it waits for a push action from the from a foreign key. So in this case we are going to be using a switch. Okay, so what this program does is that whenever we press a button from our key, the terminal will print. It will write to the serial monitor via UART, and we can test that. So now I'm going to click on the key, and it will keep writing. The moment I release the key, it stops. Now you can even use and manipulate this. If you turn off Arduino, you can even use another system to test if UART is working and whether or not you can read to the COM port. In this case, I'm using our WCH serial port debug tool, and I'm going to connect to COM port 5, which is our USB serial device, and then I'm going to open the port, and the moment I press the button, we start to receive data. And the moment I release, if I clear, you see, there is nothing, but the moment I press again, it starts to send data via UART. Now these are just the basic implementations. I will be uploading some more advanced examples. If you have anything you want us to try, any peripheral you have any questions about, please leave the comments in the YouTube comment section below. And if you're experiencing any problems, you can ask, you can make comments in the YouTube comment section, and we'll make sure to follow up after them. Or you can join our Discord server, and you can feel free to ask any questions anytime, and we'll get someone to help you immediately. So that's all for this video. If you still have any other questions, please let us know.